Hi y'all, and welcome to homework number 15 video. Man, feels like a while since I've done one of these. It's just lovely to be back. First, let's start with all the problems you can skip. That's always a good thing. We can skip these solving problems because we have not gotten to that content yet. So just skip these two solving problems. And on the back of homework number 15, for this problem here, I'm going to do a quick rewrite because we didn't quite get into addition of fraction with these. Instead, this problem is tangent of x times cosine of x times cosecant of x equals 1. Okay, because we didn't get into adding fractions. So those are all your changes and ones you don't have to do. And with that, we will get to the actual video part. So our directions here say factor completely. If I'm looking at this, I see three terms with a highest exponent of 2. So I know I can try to use my x factor on this. Remember, for my x factor, it's a times c in the top, b in the bottom. So a times c here, that's 3 times -5, which is -15 in the top. Our b value of -2 in the bottom. I'm looking for two numbers that multiply to -15 and add to -2. So if I'm looking at all the factors of 15, I have 1 and 15, and I have 3 and 5, which I'm going to stop there. I know that one of them has to be negative because 15 is negative. So I'm going to use -5 and +3 here. When I set up my factors, remember my factored form is ax plus the factor, ax plus the factor. So my a value here is 3. So it's going to be, p instead of x. 3p plus one of my factors. I'm going to use 3. And then 3p and my other factor, -5. Now a reminder, when my a value is greater than 1, I have to swing and reduce here. So I take my coefficient of a, and I swing it to become a denominator. Okay? And then I check to see if this simplifies. Okay? 3 divided by 3 would give me 1. Since this does simplify, I end up with p plus 1. Because 3 divided by 3 simplifies down to 1/1, so I'm left with just 1 here. 5 divided by 3 does not simplify any farther, so I'm going to swing that 3 right back. 3p minus 5. These are my final two factors. It just said factor here, so I don't have to solve. There's my final answer. Okay? Looking at this next one, I do have 3 terms, which leads me to think that it's going to be x factor, but you'll notice here my highest exponent is 3. Because my highest exponent is 3, I can't use x factor here. I'm going to try greatest common factor instead. So I divide up between my 3 terms. I list all the factors of 14. I've got 1 and 14 and 2 and 7. And then how many a's I have? Here I just have 1. For 21, it's 1 and 21 and 3 and 7. And then I have 2 a's here. And then here, 1 and 21 again, 3 and 7. And then I have 1, 2, 3 a's. What I do next is I circle what they have in common, or the highest value, the highest value they have in common. The highest value these have in common is 7, so I can ignore all my other factors. Okay? They also have 1a in common. So I have 1a here, 1a in common here, and 1a in common here. What's circled goes on the outside. So 7a goes on the outside of my parentheses. On the inside is what's left over. So I took out the 7 and the a, so I'm left with just 2 here. Plus, I took out the 7 and the a, so I'm left with just 3a here. And then I took out the 7 and the a, or I factored out the 7 and the a, and I'm left with 3 and 2 a's, so plus 3a squared. Okay, and that's as fully factored as this one can go. Sometimes I look to see if I could x factor in this, but this one cannot be factored. All right, next thing I'm going to look at, I skipped these problems, so I'm going to go right down to where it says factor completely here. Now these look really, really, really tricky, But the key thing about this is it's exactly the same as x factor and greatest common factor. What we're looking for here is still to factor out what we have in common. Okay? So if I'm looking at this one, I have my coefficients 1 and 2. I have sine squared of x. So that means I have sine of x twice. And then I have cosine x. Okay? On this side, I just have my 1 times 1 because this has an imaginary coefficient of 1, and then my 1 cosine of x. Again, I'm going to circle what they have in common. So they have a cosine x in common, and the largest number they have in common is 1. So I have 1 cosine x on the outside of my parentheses. And then on the inside, what I'm left over with is 2 with 2 sines of x's. So 2 sine squared of x plus 1. That's all I'm left over with here. Okay? And that is as factored as that goes. One hint I'll give you here is check for that greatest common factor, even though this one might look like an x factor. Check for greatest common factor on this one. Okay? For your ACT questions, this one is going to be an x factor as your hint, and this is going to be a special case no b value as your hint. With that, we will move to the back of our homework, looking at some of our trig identities and verifying some of our trig identities. Now, I know that these look really tricky, but it's all about problem solving here and rewriting something until you can get it to match the other side. Okay, so I'm going to go through this one first, and then these 3 will be your responsibility. So if I'm looking at this one, what's throwing me off right now is I see these squareds. Okay, so I've got tangent of x and cosecant of x, and I want it to look like 1 over cosine squared of x. Okay, so what I'm going to do, I'm going to look at tangent squared of x first. If I'm looking at tangent squared of x, there are 2 different ways that I can write tangent. I either can write it as sine over cosine, or I can write it as 1 over cotangent. I'm going to pick to use tangent is equal to sine over cosine because I have cosine on this side of the equation. I always want to pick the one that has something in common with what's already written down. Okay, so I'm going to write that first. The tricky part here is the squared. If this tangent is squared, it just means that the sine and the cosine will be squared as well. So this should be sine squared of theta, or I guess x here, sorry, over cosine squared of x. Okay, that's for my tangent of x. Next one I have is cosecant squared of x. Okay, and I know that these are right next to each other, so I know that they're being multiplied. If I'm looking at cosecant, I see that cosecant is equal to 1 over sine. Okay? If I'm looking at that, well, I have a sine in the top of this fraction, or the way that I just rewrote tangent, so it might help me to have another sine in this equation. So I'm going to use this identity for cosecant and rewrite this as 1 over sine squared of x, because again, we've got a squared here, so we have to have that with our sine as well. Okay, and that should be equal to the other side of my equation, cosine squared of x. From here, I look at what can cancel out, because at this point, I've got sine in common and I've got cosine in common. Well, I see that I've got a sine on the top of this fraction being multiplied this fraction by the next fraction where sine is on the bottom. If I have sine squared of x on the top of the fraction, it can cancel out with sine squared of x on the bottom of the fraction, so these will cancel. If these cancel out, I'm left with just 1 in the top here. So 1 cosine squared of x times 1 over 1, because the sines canceled out, is equal to 1 cosine squared of x. Okay, equal to 1 cosine squared of x. Now, I know that 1 over 1 is the same thing as 1, and anything multiplied by 1 is itself, so I can write my answer as 1 cosine squared x is equal to 1 over cosine squared x. The left-hand side of the equation matches the right-hand side of the equation. I have verified this to be true. Just don't let those squareds throw you off. My one hint for you on these ones is particularly with this one, you end up dividing fractions. So remember your same, change, flip. Your first fraction stays the same. You change division to multiplication, and you flip the second fraction. That's how we divide fractions, our same, change, flip. For these down here, these are both going to end up as X factor for your ACT problems. Both of these end up as X factor. All right, that is enough hints and helps. Happy mathing, happy trig functions, if there is such a thing. So that's it. Like and subscribe.